Welcome back to the class. R for journalists. We're going to go over a case study using what we've learned with dplyr and tidyr and joining data and wrangling data. And we're going to look at more thoroughly the data set that we've pulled from the FBI from the Murder Accountability Project. So the FBI has tracked more than 750,000 murders in 40 years across the country. And that's not counting the police departments that refuse to send them their homicide statistics. So Thomas Hargrove was a national correspondent at the Scripps Howard News Service, where he developed an algorithm that uses FBI homicide data to identify areas of murders that had an elevated probability of containing serial killers. So we're going to go over his algorithm and try to reproduce it. So let's start by considering the case of the Green River Killer, Gary Ridgway. So he murdered at least 49 women in Washington State before he was caught in 2001. Some things to note: he began murdering women in 1982 and was caught in 2001 when DNA testing connected him. He told investigators he killed as many as 75 to 80 women along Route 99 in South King County, Washington. He brought many of them to his home and strangled them and then left them in woodsy remote sites. Okay. So how would you find victims, those particular victims, in our data set? There are definitely patterns. It happened in King County, Washington. The time span was between 1982 and 2001. The victims were all female. They were often strangled. And they were found in remote locations. So let's bring this data set back in. I'm in the case study folder. Case study RMD. Hopefully you can cut this, Ryan. Thanks. Okay, you've imported the data. Let's take a look at the data set. First of all, let's try to first figure out all the murders in King County. The only problem is the metro areas are labeled, but the counties are not. The only county identifier we have is the Phipps code. That's a problem. Fortunately, I have a relationship file for you. All you have to do is bring it in. I'm going to just click this green button, moving along. County Phipps. Okay, so now we have the Phipps code. Name of the county, state, county. So it will now join to this easily. And a couple of other little details. I'm going to fix a couple of the Phipps codes in here manually, because sometimes Phipps change, especially after decades. Boundaries change, IDs change. So let me describe what's going on here. So I'm repurposing murders. I'm turning the county Phipps into numbers, but I'm first converting into characters, because if you glimpse murders, you see that Phipps is a factor. And if I change that to numeric right away, it would not give me the right numbers as you see here. It would give me like 1, 2, 3, 4, 5. Because that's how R would interpret it. So we need to be very careful when converting factors into numbers. You got to first convert it into a character and then a number. So then I'm creating a column, and I'm pretty much just turning county FIPS and replacing a number. So every time this number shows up, I want it to be this number. If this zip code shows up, this county FIPS shows up, I want it to be that number. And if it's none of those, then let it remain the number it already was. And then I'm joining it to county FIPS, left join, by, and the key that I want to join them on is the FIPS. And even though the column names are different for both one, it's going to work because I've labeled it with the by. Murders. Okay, so there it is. I've got the name of the county, state abbreviation, and it's all appended to the end of the murders data frame. So that worked. Now we can filter it based on the other criteria. King County, right? There's King in there. That's going to take a while because there's 750,000 rows, so let's just do it quickly this way. So Greenway 1 is what I'll call this new data frame. Murders, filter, and state equals Washington. And name of county is King. 2 equal signs. And then I want to pipe it based on the other criteria, which was filter again, year. All these happened after 1982 and before 2001. And the last thing was filter. The gender was female. I'm gonna press escape because it's got some leftover code from before. If I press escape, that'll cancel that. So now I can select this, run it. Okay. So we've narrowed it down to 510 cases by filtering it with King County, Washington State, between particular years, and look for female victims. How many were strangled? Is there a distinction for that? What type of weapons are labeled by officials? So we can figure that out quickly by starting with the data frame, murders, pipe it to select, because we only want the weapons, and then pass on the function unique. Run that, and these are a number of them. So what was Ridgway's method? Maybe strangulation, and yep, perhaps other or type unknown. So let's throw that in there as well into our filtering. Filter. Yeah, let's sorry about that. How many in the ones that we've already filtered from Greenway 1? How many are there out of those circumstances? And I can just use the function count, which is another quick form of summarize. So they gave me n. But I want to sort it by n, by the most amount. So descending n. Let's try that again. Circumstances undetermined. Okay, that kind of makes sense. There's not really a category for left in a ditch in the woods. Unfortunately, it's pretty vague, but those are the options that the authorities came up with. We should be clear that there's no way to tell that this data set from this data set that the filtered data that were sliced out are all victims of Gary Ridgway. That would involve looking up all the case files for each victim, or researching the evidence as presented at his trial. Still, there's a decent chance, based on his confession, that some of the victims were listed in here. Okay. So put yourself in the mindset of a detective or a criminal profiler. Can you reverse engineer the process of narrowing down the list of victims here and apply it to the data set that we have to surface areas, counties, or metro statistical areas where serial killers might be murdering with impunity? So what were the list of patterns you could wrangle the data for? Areas with low rates of homicide clearances. Murders span years, even decades. Victims are similar in gender. The method of killing is often repeated. So let's talk about the algorithm. So Thomas Hargrove noticed these patterns as a journalist and developed an algorithm that would locate these clusters of murders that show these signs. Here it is programmed in SPSS. So you'll notice you notice that the syntax is a little bit reminiscent of what we worked with in dplyr. So it says, so there's pretty good comments documenting it. So it says get the file. If it's solved, then equals 1. If it's unsolved, 0, etc. Victim, gender, county, and then he builds it out, and he looks at the weapons as well. So let's translate this into R. So specifically, case status is either 0 or 1 based on solved or unsolved. We can use mutate and case when for this. We look at the gender of the victim, and he's creating clusters based on counties or the metropolitan statistical area. And he's looking at gender, and he's looking at weapons. So those are the priority variables that he's established. And so to replicate this, all we have to do is just group by. So let's start out with the MSA group, and we'll start with murders and pipe it to mutate, and we want to get a solved number, right? And that's if else. I'm going to pass the if else. Actually, I can do case one. So if solved label is a yes, then that's a 1. Right? Do you give it a 1? Yes. Otherwise, it was a 0. Alright, solve label. No. 0. Okay, next thing we wanted to do is now pipe to group by. And what were the factors? It was MSA, label, gender, and weapon. And then, you can see here, he aggregated it. So all we do is just do cases equals n, and then we figure out the number of solved. And because we've created a variable already, and with mutate, he just adds of sum of solve num. And then you can pipe that to another variable to figure out the clearance rate. Equals round solved, because I'm going to round this number, solved divided by cases times 100, comma 2, because I want to round it to 2 digits after. Okay, I'm going to pipe that to data table. Don't forget to load library DT to enable data table. Gotta make sure you spell data table correctly. That's why. No, you know what? I don't need to pipe it. I need to pass a variable to it. Let's try it again. Okay, so based on this cluster, we have more than, based on this algorithm, basic algorithm, we have 10,000 clusters. So our group says we can filter it even more. So we want to look for female victims, and we want to look for areas where clearance rates are less than 33%. Create a new group called MSA group filtered. MSA group filter. Label equals female, and clearance is less than or equal to 33. And just so we're getting rid of these cases where it's just, I mean, it's a serial killer, so that means it has to happen serially. It can't just be one victim, so there has to be more than one case. And I did that error where I only included one equal sign, and that's not going to work. So, putting it. And also not working is misspelling things. Try it again. Okay, that's because I spelled clearance wrong. And you know what? That's the great thing about scripts is if you do something wrong, you just fix it real quick and then rerun the lines of code, and then everything lines up. So let's take a look at data table MSA group filtered. So I went from 10,000 cases down to 151. It's pretty impressive. Although I think when I've done this before, I even filtered it even more than 99 even? What am I doing differently? Clearance, traces. Okay. Well then. So let's expand the scope from MSA to counties. So all we need to do is let's just rework all this code. I'm gonna just copy and paste now for counties. New to Mac. Yeah. Let's see you later. Okay, so I'm going to rename the new data frame called county group, and I'm not going to group by MSA label. I'm going to group by county and state. I'm going to keep everything else the same. I'm going to combine these two steps and just pipe it into the next. So easy. This time I'm going to add a function for arrange, because I want to see areas that have just a ton of cases. I'm going to repair that. So let's run this, all this code. Okay. So why am I focusing on counties and not just MSAs? Because MSAs are smaller than counties. Counties are so large that they're often covered by multiple agencies like sheriff's departments, police departments, state police, and they each focus on their own different jurisdictions. Serial killers aren't limited by their geography. I mean, to some extent they are, but they don't pay attention to borders. So it's important to expand the scope, and counties are pretty large. So we've narrowed the clusters down. So let's go to the search bar and look for King, Washington. And there we have it. We have 108 cases for women. Only 31 have been solved. That's a clearance rate of about 29. Oh, that's why. It's because of this 2. Forgot a parenthesis. That's what's throwing things off. That's why I didn't have everything lined up correctly. Okay, what's going on? Oh. Misplaced parenthesis. I don't need that there. I don't need that there. So let's rerun these. So easy to fix. No errors. Beautiful. 325 cases. That lines up with my walkthrough. Yay. Okay. So looking back at the King, Washington. 28% for clearance rate. So Ridgeway's 75 to 80 victims are probably among them. So let's expand the scope a bit. Now that we have the basics of this algorithm, it's basically an illuminating way of grouping and wrangling data. We can add more customization. We don't have to exclude the genders of men and women. We can limit the scope to the latest 10 years of data, all by adding or adjusting filters. So let's do that real quick. I'm going to focus on counties. Once again, copy my code. I'm just really attached to it. And just keep on adjusting based on what I've already done. Create a new data frame called County Group 2. And this time, I'm going to filter it before I mutate. And just focus on the years between 2006 and 2016, the past 10 years. And remember, if I have multiple years to filter by based on one variable, I could do percent in percent. 2006, 2016, and then just pipe that in. So I just fit one line in between the code we've got. It's beautiful. And what else? I don't want to filter it by victim label anymore, so I just delete that. And is that it? Yeah, I think so. Okay, change the name of data table. Run that. Let's see what we got. So we're now at 320. Cook County, Illinois seems to have a big issue with men getting killed and not getting solved, their case not getting solved, at 26.6% clearance rate. That's probably not the work of a serial killer. That's just a lot of gun violence. So we've narrowed it down. We can keep going. Do you think a killer might be targeting a specific age group? You could filter the age like we did the years, We can add in another line specifying age if we want. Or we could create age categories with the data. See, categorical data has been very useful so far. I mean, we've got gender, we've got whether it's solved, we've got county, we've got MSA. We can turn a continuous variable like age into a categorical variable by dividing it into bins. So we can use case when with mutate from the dplyr package. So let's go back to the murders data frame. Right. And there's the age, victim age column. So we want to create a new column called age group. So this is what we'll do. Start with murders, and we're going to rerun it over itself, just to save over itself. Murders, start with murders again, pipe it to mutate. And age group equals case when, parenthesis, and this is when we're going to start grouping things up. So vic age, and we're going to use in again, the percent in percent, 0 through 14, tilde 0 through 14 as a string. And we'll do this a few more times. Copy, paste, paste, paste. We only need about 4 of them, and let's see, 15. What's a like teenagers? 15 to 19. So let's change that. 20 through, I guess let's make this broad. 50. 20 to 50. And then 51 through 99. And if the age does not match any of those, fall in the range of any of those, you know, in case there's like a 999 again, then just fix that with a true, tilde unknown. Okay. Great. So let's rerun this. Keep an eye on murders in the object environment. Now we have 51 variables. I'm sure if I click it, it'll show up on the right. So now let's repurpose this county group again, county group 2, and now rename it, you guessed it, county group 3. Keep everything else the same. I'm going to add another group in here called age group. You guessed it. And that's that. Let's run it. Little awkward, 666. Let's add the female factor back in. Why are we doing the female 196? Well, I mean, I would say a lot of the FBI profilers say that serial killers tend to focus on women. I don't know if I agree with that. Maybe that's just traditional thinking imposed on these type of acts. Who knows? So, but for now, we'll just narrow this down. You can always go back and change the filters however you like. So now we have 196. And we see St. Louis. Firearm, so maybe not firearm. Let's see. Other type unknown. Here we go. Bexar, Texas. 27% clearance rate for adult females. Ohio, Suffolk, Massachusetts. Well, no. Firearms, not so much. Blunt object. Dallas, Texas. There's a number of them on the elderly. Okay. So, we've looked at the algorithm. We've looked for evidence of serial killers. I hope this was instrumental in showing you how to approach data to discover insights. I'll see you in the next section where we handle strings and then we handle dates. It won't be quite as involved as this.